Hello.
Yes, sir. We can hear you.
Yeah. So,
Let us start. Good afternoon, everyone. We now come to the final academic session of this refresher course, and it gives me great pleasure to moderate this concluding lecture. The lecture will be of 1 hour and 20 minutes, followed by 10 minutes of question and answers. During the lecture, participants are requested to post their questions in the chat box. I will select the questions and I'll raise this in question and answer session. We kindly request everyone to keep their questions concise and focused on the topic. It is privilege to introduce our speaker for this session, Professor Sanjay Gupta. Professor Gupta is currently chairperson of the Career Development Center and professor in the Department of Mechanical Engineering at the Indian Institute of Technology, Kharagpur. He has more than 27 years of teaching and research experience and is in charge of the biomechanics laboratory at IIT Kharagpur. Professor Gupta obtained his PhD from Delft University of Technology, the Netherlands, and has held research positions at University of Southampton and Imperial College London in the United Kingdom. He has around 100 publications and supervised 10 PhD scholars. And since August 2022, he also holds an adjunct faculty position at IIT Delhi. He is recipient of the INSA Teachers Award 2022 and very recently in July 2025, a textbook entitled Biomechanics of Joints and Implants Concept to Application, authored by him and his former doctoral scholars. It has been published by Springer Nature, Singapore. Today, Professor Gupta will be delivering a lecture entitled Recent Trends in Orthopedic Biomechanics and Implant Design, Numerical and Experimental Investigations. Professor Gupta, thank you for joining us. We look forward to your lecture.
thank
The
you.
floor is yours, and you can start, sir.
Okay. So, good afternoon, everybody. Myself is Sanjay Gupta from IIT Kharagpur. I'm professor of mechanical engineering, and have been kindly invited by Dr. Shom from Maulana Azad College, and I'm honored and privileged for the invitation. Today's lecture, I would like to share the screen. Can everybody see that? Hello.
Yes, yes.
Yes, sir.
Yeah.
Yes, sir.
So today's lecture is on the recent trends in orthopedic biomechanics and implant design, numerical and experimental investigations. Now, this topic has been, particularly the topic biomechanics, has been quite popular nowadays, and I do have an NPTEL course on orthopedic biomechanics and implant design, already running for 5 years. So we have completed 5 years of that course, and my lecture would be based on the highlights presented in the course as well. Okay. So if anybody is interested about more details, and they can subscribe to the NPTEL course, particularly the students, because a huge amount of students and faculty members also from medical institutes are subscribing to the course. And I hope you all know about the NPTEL platform, which offers a substantial number of courses in many subjects. Okay, so this course is offered under mechanical engineering domain, although this is an interdisciplinary area of research. But I am a mechanical engineer, and now I contribute in the field from the point of view of a mechanical engineer. Okay, so there may be things that might not be entirely, the students might not be entirely conversant with, but I would try to present it in more in layman's term. But few scientific things, particularly the root physics to mathematics to computational methods, as well as experimental techniques, need some background of solid mechanics and sort of strength of materials to some extent, which are actually basic subjects of mechanical engineering. Anyway, so let me just try to start my lecture. So, just a moment, let me find the pointer. Yeah. Joint replacement, as you might know, is becoming popular nowadays. There is a clinical need for joint replacement. And basically, there is a huge number of patients who suffers from pain and restricted movement. And that basically results in reduction of the quality of life, particularly for elder generations. It is also nowadays common with younger generations, but it is basically concerned with damage within major joints like hip, knee, shoulder, and elbow. Okay, and the main diseases that is causing this, problems and leading to joint replacements are osteoarthritis. 75% are joint replacements, fractures, traumatic fractures like road traffic accidents, rheumatoid arthritis comprise about 4% of the population, and others about 7% of the population. Now, if we go towards look at the treatment, you see, let us take, for example, one of the load-bearing joints. I hope you understand what is meant by load-bearing joints, because the upper part of the body, if we have the human body, we have upper part and a lower part. So the lower part of the body provides us stability against loads. Loads means forces. And the upper part of the body, as compared to the lower part, gives us more mobility than stability. Okay, so if we consider shoulder joint, that is probably the most mobile joints of all the human joints that is within the human body. The shoulder joint provides us the maximum range of motion. However, the joint is less stable as compared to the hip joint, which is essentially a ball and socket joint. Okay. Now, we will be considering in this lecture concentrating more on the hip, because that gives you some idea of what are the unique problems associated with joint replacements. There are some common problems and there are certain unique problems related to specific joints. Okay, so we would consider this lecture mostly focused on hip replacement. As you can see here, you can see a ball and socket joint, and you can see the ball is the femoral head and the socket is the acetabulum. Okay, and we have the longest and the strongest bone that comprises of the hip joint, that is the femur. The pelvic bone, within which the acetabulum is located, is also quite a large bone, and quite a large and strong bone. Now, you can see that there are two types of joint replacement in the hip. So one is a ASR, articular surface replacement, or resurfacing hip arthroplasty. The other one is the conventional total hip replacement. An example, Synergy implants from Smith and Nephew. Now, in both the cases, you have to undergo some major surgical operations. And these sort of surgical procedures involve mechanical, machining of the bone. Okay, it seems to be, apparently very painful, but everything is done under anesthesia, general anesthesia. And you can see that in case of surface replacement, we have minimal invasion. Only the articular surfaces are replaced. And in case of the total hip replacement, you see the proximal part of the femur is completely removed and replaced by a bulky implant, which actually inserts into the femur. Now, the next question is how to fix the implant with the host bone. Okay, so we have a cemented type of fixation, and there is also uncemented type of fixation. Now, cemented fixation, which is an age-old method of fixation of the implant to bone, consists of a material called bone cement. It is similar to our building cement material. It has some properties quite similar to the building cement material. It is basically a polymer, polymethyl methacrylate, PMMA, and then when it is mixed with the monomer, it solidifies with time and then helps the implant to be fixed within the host bone. The cemented fixation gives us almost immediate fixation of the implant with bone, but there are certain unique problems related to cemented fixations. On the other hand, we have the uncemented fixation, which are more common nowadays because of the inherent problems with the cemented fixation. Uncemented fixation, as you can see here, it has basically a biological fixation of the implant with the bone. So this is all about osseointegration, as we commonly call, as the clinical world commonly, they look at the problem, the fixation problem between the implant and the bone as osseointegration, or the degree of osseointegration. Higher the degree of osseointegration, the higher the strength is between the implant and the host bone. Now, how do we achieve this biological fixation? The biological fixation is achieved by a porous coating on the host implant. This porous coating is available on the implant, and with time, bone grows inside the porous coating, giving rise to a mechanical interlock and bone bonding capability. So if I look into more closely into in this figure, you can see that bone and granulation tissue actually grows inside the porous layer, facilitating osseointegration. Now, when we are taking up implant designs and analysis, the first thing from engineering point of view, for any applications, we must be aware of the failure mechanisms. That is the worst case scenario. What can go wrong? Okay, that means what can go wrong. Now, the failure mechanisms from the last 30 years of research has been generally 3 types. Accumulated damage failure scenarios, where the interface stresses leading to implant bone interface debonding. So the interface stresses within the implant bone configuration may be too high to withstand the interface bond strength. So if the stresses generated become higher at any point than the allowable limits, it will lead to failure. There is also excessive implant bone relative displacements that affect the primary fixation. So when you actually press fit, now what is press fit? Perhaps you know that when an object is forcefully pushed inside a cavity, that is called a press fitted scenario. Okay, so there the object has a slightly greater dimension than the available dimension of the cavity. Now, this situation is often adopted by surgeons to actually fix the implant primarily inside the bone. So it helps in primary fixation. Unless if you don't do that, then what happens? For uncemented implant, these implant doesn't get any primary fixation, doesn't get any primary hold inside the bone cavity. Okay, so sometimes in general practice, it is the surgeons use a press fitted approach to push in the implant inside the host bone cavity. Okay, however, with time, if there is not much of a bone ingrowth, that is, if we consider the what should I say, the uncemented implants, if there is not sufficient osseointegration, as I had discussed just a little bit earlier, then there are problems of fixation of the implant, and the implant bone relative displacements are excessive. If it crosses that a limit, then it induces loosening within a mechanical loosening within the implant bone structure. The second point is particulate reaction failure scenarios. This is connected with wear and abrasion. Okay, continuous use. So you expect a patient being operated by a surgeon, say hip replacement, he or she undergoes a hip replacement. What is the objective? The objective is basically to offer the normal range of motion. So a patient can actually come back to normal life, can do normal activities like stair climbing, walking, sitting down on a chair, getting up from a chair, getting into a car, all normal activities. Now, this state of loading and unloading, it is basically a dynamic loading conditions, and it gives rise to wear between articulating surfaces as well as abrasion in the different interfaces constituting the implant bone configuration. So with continuous use, these materials may give rise to wear particle debris, and these wear particle debris actually are highly hyperactive, and they react with bone and blood. Okay, so this is a long-term problems that exists within the inherent surgical procedure of joint replacement. This is common for all. Okay, so wear-resistant materials, evolution of wear-resistant material that would give rise to less wear debris inside the human joint capsule is highly desired. The third important failure scenarios is also, bit on the long-term side, is stress shielding and bone remodeling. Now, in the normal condition, say for a normal person like all of you who are leading a normal life, bone exists in an equilibrium state of stresses and strain. So there is a mechanical environment within the bone tissue. Now, if we intervene with a major surgical procedure like joint replacement, it actually gives rise to a major change in the mechanical environment of the host bone. Now, bone is a highly adaptive material. It can undergo changes in structure due to changes in the mechanical environment. So, the moment you induce a foreign material inside the bone structure, bone starts responding to this induction by changing its own structure. So in some cases, there is an adverse effect of bone loss. In some locations, there may be bone apposition or bone density increase. Now, how do we assess all these problems? Now, the first thing what needs to be addressed is the implant sufficiently well designed to address all these various scenarios? The answer may be yes or no. We don't know. How we can know? There are two ways. One is clinical way, that you implant it within some patient and wait for the clinical feedback, which is dangerous to some extent. Okay? Because the adverse effects of failure will affect the patient. So, over the last 30 years, there has been a huge, effort that went into preclinical analysis. That is, using finite element models and finite element analysis based on precise CT scan data of patients, both for natural bone and implanted bone. And it has tremendously contributed towards the orthopedic research to test and validate clinical hypotheses. So in many universities abroad, particularly I have worked in Europe, and so I have the idea that there are research groups that work in mechanical engineering. They are working very closely with the hospital and, extracting patient data, making models, and then trying out different designs of the processes just to get an idea that in advance what can actually go wrong. Okay, so it is a predictive model, and the predictions are in many ways important towards getting an optimal design for which will be beneficial for the patients. So we call that procedure in a summary as preclinical analysis. I would focus my lecture more on this preclinical analysis and also on validations which are necessary to accept the results of to accept the predicted results coming out of these finite element analysis. Let us consider, for example, hip resurfacing arthroplasty. So how did we define that this was a surface replacement, essentially a surface replacement. The articular surface is machined and an implant is inserted. Now, it has been observed that clinical studies, immediately after surgery, when the patient is trying to come back to normal life, there has been clinical studies which report femoral neck fracture as the most common short-term failure mechanism. In the long term, there has been also the effect of stress-strain shielding leading to bone remodeling, finally causing implant loosening. So both the failure mechanisms actually affected directly the patients, and this was highlighted in 2008 Journal of Bone and Joint Surgery, American volume. And I had the opportunity to work with DPU Johnson & Johnson in the United Kingdom. And that during that time, this, there has been a big, investigations on the mechanical causes of failure that was leading to finally the biological failure of these implants. And it was found that stresses and strain actually are causing the short-term and long-term failures. So I'll try to explain you in short how these things were done. So we started with a finite element analysis of an intact and implanted femur. As you can see on the left, we have the finite element model developed from CT scan data. So we use CT slices through layer reconstruction method. We actually make the solid model, and thereby we actually mesh it using the finite element measure. Now, the problem with these models is that how do we incorporate the heterogeneous bone material properties in the model? So there are standard ways of doing that. So you need to analyze the CT scan data, and from CT gray value, you can actually relate it to the bone apparent density, and from apparent density, you can relate it to the elastic modulus through power law relationships available in the literature for different types of bone. Now, this finally gave us a finite element model of about 1 lakh elements, where each bone element was assigned individual material properties based on a CT gray value. So if I look at on the right, you can see, if I look into the mid-frontal section, coronal section of the implanted joint, you can see the green is the mushroom-shaped implant. It has been cemented, so the yellow colored layer is the cement layer, bone cement layer. And this metaphyseal stem, the surgeons prefer to have a long stem, which actually they use it as a guide for positioning the implant so that the mechanics is preserved to the extent possible. Okay, but there is an overreamed hole, and you can see the metaphyseal stem going inside the overreamed hole. But this doesn't take part too much into the load transfer. That was the original surgical procedure. Now, where we actually tried to intervene and change the surgical procedure in such a way so that this implant can be beneficial. It not only led to change in the surgical procedure, it also led to change in the design of the implant. Now, how do we assess all these stresses and strain fields? We use the loading conditions, and you can see here, walking, stare down, stare up, sitting up from a chair, sitting down on a chair. So you have the muscle attachment sites, and the shaded regions represent basically muscle attachment sites of different muscles that are relevant. And of course, the loading is the predominant hip joint reaction force or the hip contact force, muscles, and constraints. Now, what is this adaptive bone remodeling? So this adaptive bone remodeling is a phenomenon of the bone tissue, and it explains the response of the bone tissue to significant alteration of its stress-strain mechanical environment. So remember one thing, that the whole bone remodeling simulation as of now, as I explain you, is based on loads. There are other factors like metabolic factors that can also affect bone remodeling. But the predominant factor that affects bone remodeling after implantation is load driven. So let me just explain you in short and easy way how we actually do the formulation and implement in form of the computer simulation. Now, bone adapts its structure in accordance to altered mechanical environment by the process of bone resorption, which is essentially an activity of the osteoclast, and bone apposition, which is an activity of the osteoblasts. The rate of bone loss or gain is basically related to the difference in the mechanical stimulus. Okay, so this is a very important parameter that governs the bone remodeling process. Now, S minus SREF, or the difference S and between S and SREF, is the driving force that triggers bone remodeling. And what is S? S is the remodeling signal, that is the mechanical stimulus in the implanted bone, okay, that is after surgery, which is expected to change due to implantation. Now, what is SREF? This is the reference signal, the mechanical stimulus in the intact bone, which has not undergone surgical procedure. So this is the natural bone. So we are comparing two different states of mechanical stimulus. One is after implantation, with another one is before implantation. So the difference is basically the driving force that triggers bone remodeling, as I already said. Now, what is this mechanical stimulus? Mechanical stimulus is strain energy per unit of bone mass averaged over the loading history. So these are all solid mechanics sort of terms which you may not be, I exactly don't know the backgrounds of the audience, but these are arising, quite commonly used for structural analysis or of machine elements or structural elements. And these are very common words that are, people from technical background, particularly mechanical or civil engineering students, know that pretty well. So here the elastic strain energy UI per element corresponding to a load case. Then we have the total number of load cases. If it is, as I explained to you, we have load cases from arising out of different physiological activities. If it is 5, then the number is 5. If it is 4, the number will be 4. And rho is the bone apparent density. UA basically is the strain energy density of an element averaged over the number of load cases. So we do an averaging so that the variation of mechanical stimulus due to different physiological activities is accounted for within this quantity, which is designated as the mechanical stimulus. One important point to note here is that bone doesn't react to small deviations in mechanical stimulus. If the deviations are minor, when we say before and after surgery, then bone doesn't react to small deviation in the mechanical stimulus. So there is a minimal threshold of the inhibitory signal that is required for triggering bone remodeling, and this was later incorporated in the theory as dead zone or lazy zone. Okay, so what is that? We will get to know in the next slide. Maybe a little bit. I don't have it here. So the deviations in strain distribution, as you can see here, in case of stair climbing, so this is the strain distribution in case of intact femur, the natural case. After implantation, you can see the changes in the mechanical environment, particularly strain distribution. Okay, and you can see here, as I point with my pointer, you can see here at the junction of the implant cement and bone, there is very high strain, which is the primary cause of the fracture that I shown you earlier. If I go back, you see here, you see a black line progressing from the top superior part of the femoral neck and progressing towards a catastrophic failure of the whole new surgical construct. Now, we had published this work quite some time earlier in 2009, and thereafter you can see that this is the area which is triggering the crack initiation and crack propagation inside the implanted bone. Now, I just gave you a glimpse of how these predictions on numerical simulations are useful in identifying some clinical failure, which are actually difficult to analyze using just patient feedback data. Now, clinical failure is something which is real, okay? Computer simulation has lot of problems, okay? And personally, I've been working with it more than 30 years, and I don't believe computer simulations, okay? For some people, it is a holy machine. Everything comes out of computer is acceptable. For me, no, it is not acceptable, okay? You never know where you have made mistakes. You might have made mistakes in input variables. You might have made mistakes in procedural steps. And finally, what comes out of the black box, whether or not it is useful or irrelevant, depends on finally on experimental validation and verification. So we had undertaken this project in a collaboration with the University of Southampton under the UK-India partnership program. And our PhD student had, done some experimental validation. We had designed and fabricated some special loading mechanism, as you can see on the right, that simulates the loading of the hip as it would be in case of a natural femur. And then this had a implant, as you can see here, the shiny implant, resurfacing implant. And of course, this bone is not real bone, it is synthetic bone. It's called saw bones, and it's quite expensive to get, and we fortunately could afford it from our project. And there is a strain gauges mounted on it, as well as LDSs, linear variable differential transducer. They actually measure the implant bone relative displacement and along three orthogonal directions. So we had LVDTs 1, 2, and there was one LVDT which was trying to measure the movement of the tip of the stem that goes inside the bone. Now, when we compared experimental strain versus the numerically predicted FE strain, we did get some very good agreement. So this is all about statistical analysis. I hope many of you are conversant with it. So you have to really compare the raw data of the measured strain versus the finite element strain predicted by the FE models. And this is what we get. So R 0.94, slope 0.86 with intercept minus 0.109 microstrain. And in case of resurfaced femur, we see even a greater correlation coefficient and less intercept. So the slope is supposed to be actually more close to 1, and intercept, as you know, y is equal to mx plus c. So if it is if it is fully in agreement, then slope m should be equal to 1 and c should be equal to 0. But this is not always the reality. Reality is when we actually test data. So the symbols basically indicate strain gauge output for all load cases. But we, in a way, may conclude that the finite element models are actually predicting values which can be accepted for clinical relevance. If you compare sort of also measured and FE micromotions, micromotions actually mean implant bone relative displacements. So here we are comparing in along different directions. So this is the measured values, load versus displacement. Displacement actually means implant bone displacements, and then the comparison, which is reasonably acceptable. We published this in the topmost journal of our field, that is Journal of Biomechanics, in 2010. Now, we did come up with predicting successfully the causes of failure. But what is the step forward? Is this implant? The implant was eventually removed from the market because there were many lawsuits against it, and so what we had taken up as a new project was to develop a new implant. So if we try to address and learn from the mistakes, address the problems associated with the implant, we need to go to the very basic level. Now, if I see a coronal section of a natural femur, so this is a radiograph of a coronal section from the proximal femur, which is showing the trabecular orientation. That means trabeculae are the porous bone, okay, trabecular bone or cancellous bone. The orientation of the cancellous bone or the trabecular bone are known as trabecular orientation. And there is a basic, understanding that bone grows according to the mechanical load it is subjected to. So you can see that all the trabecular bone orientation is along the load transfer path. Okay, so this is something we try to study and learn how to design an implant which would give me a stress strain distribution similar to a natural femur. So on the right hand side, you can see that this is the stress distribution in a natural femur. What our objective is to minimize the deviations of this stress strain distribution as compared to the natural femur. So what did we do? We tried to make it the metaphyseal stem. The metaphyseal stem originally was this size. We tried to optimize the length of the metaphyseal stem. So earlier this dimension was equal to the diameter of the femoral head. Now we arrived at a dimension which is d/2, that is equal to the radius of the femoral head. The red line, as you can see. And interestingly, this gave us a completely different picture of the stress distribution as compared to the earlier long stem version. So here comes some of the results. The long stem, we did simulate friction between the stem and the bone. This is immediate postoperative strain distribution. For short stem, you can see here, the strain concentration is more at the tip of the stem. And although there exists some amount of elevated strains, this elevated strains was quantitatively less compared to the original long stem implant. Now, what are the predicted changes in bone density if we compare long and short stem designs? You can see here for long stem, this is the predicted bone density changes based on bone remodeling theory. And in case of short stem, instead of bone loss, we actually see some bone gain in this region. If you compare directly the second picture with the third picture, after equilibrium in bone remodeling, we see a more favorable bone density distribution as compared, if you compare it with the original bone density just immediately after surgery. So bone density doesn't change immediately after surgery. So this is basically the original configuration. And this is the configuration after bone remodeling. Short term, a short stem and the long stem. So you can see that this is the second picture or second figure gives you more favorable stress, bone density distribution as compared to the long stem design. If you actually compare the normalized peak strains over time, that is over bone remodeling, you can see that for the short stem design, the red one, the red line with the triangles, compared to the long stem design, you can see that how design is affecting the chances of failure. So in case of short stem, the normalized peak strain is to some extent less than the long stem design. Now, from zero, number of iterations is related to number of days after surgery. So 0 day means the surgical day, immediately after surgery. Now, the critical period of rehabilitation is between 0 to 5. So in many cases, the patient is advised to undergo partial weight bearing, okay, by using crutches, so that during this immediate post-operative critical rehabilitation period, you can avoid high strain and let the bone heal with time and offer more strength so that there is no failure initiated from the superior femoral neck junction with the implant that causes this failure. Now, the next lecture that I would sort of focus on is on the pelvic bone and optimal design considerations of uncemented acetabular prosthesis. Now, we had focused on earlier on femoral implants, and now we'll be moving into the more critical acetabular component loosening. Now, clinical feedback studies reported acetabular component loosening to be 2 to 3 times higher than the femoral component. So you have this very complex pelvic bone, and you can see very clearly on the left the acetabular cavity, which is the socket. And there has been several designs arising in the market. It says a Cambridge cup, Mitch cup, polymer composites coming into these implant designs. Oops. What happened? Yeah. Sorry. Now, one of the major causes behind this aseptic loosening, failure of the implant, is considered due to mechanical factors. So, combined with that, those clinical feedbacks and desired investigations regarding the mechanical factors behind these failures, There was another demand that was arising. The demand for more durable implants were increasing because more and more young and active patients underwent joint replacements, thereby triggering more, more increase in the life expectancy of also the older patients. So, coupled with younger patients and the increasing life expectancy of the older patients, the demand for more durable prosthesis serving the affected patients were increasing. Oops. So again, if we look into, there is the same procedure of generating finite element model of intact, means the natural hemipelvis and the implanted hemipelvis models based on the procedure that I already explained. But here the equations are different because it is a different bone. It is pelvic bone, not the femur. So we have different calibrations for allocating bone material properties. So finite element of the intact natural hemipelvis in this case had about 222,000 elements, and for the implanted it was also around that 220,000 elements. Two extreme acetabular implant bone interface conditions were analyzed, one with fully bonded and the other debonded exact fit interface having mu is equal to 0.5. Mu is the friction coefficient between the implant and the bone. Applied loading conditions, we have been analyzing the gauge cycle, and from the gauge cycle we have chosen about 8 load cases. As you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 8 instances of the load cases. And each instant had a set of 21 muscle forces and hip joint forces. Okay, and the constraints that were applied to these models were mimicking the physiological constraints, which is fixed boundary conditions at the pubis and the sacroiliac joint. We had actually been very careful about how to distribute the predominant hip joint force from the center of the femoral head, how it will be transferred onto the pelvic bone. And we actually modeled the cartilage layer in between so that, and of course, there are bonded and debonded interfaces. And this, in a way, we can mimic the natural load distribution from the femoral head to the acetabular cavity. Okay. So there was a question, I believe. Can we address that at the end? Or would you like me to address it now?
Yes, sir, you can address it at the end.
Okay, thank you. So this is basically the more precise anatomical configuration of the femoral head with the cartilage layer. And you can, we have investigated several ways to do that. What happens if we directly apply the load? So if you directly apply a load on a point, there is always the problem of singularity creeping in. So a point has a minimum area. So a high load on a minimum area means the result is infinite. Okay. So mathematically, it is not a favorable situation. So we always try to distribute the load in such a way that it mimics the natural distribution. Okay, so we have to be careful in all these methods and to be very careful and critical about the results we predict from these finite element models. Oops. Yeah. Now, if we look into some of the stress distribution, the natural stress distribution, so this is the second load case where we have the highest joint reaction forces, which is more than 2 times the body weight. Okay, so even in normal walking, when you are walking, you maybe a little bit now become more careful that you reach, you say, average weight, if we consider 70 kilograms, then every time you undergo a walking cycle, you are generating a force which is more than 2.3 times the body weight. Okay, each and every walking cycle. Okay, so I hope the audience would be careful about their body weight, because these are huge loads. Okay, and they can really cause a lot of problems for obese patients, particularly in joint replacements. Now, this is the natural stress distribution. So we have, for the maximum hip joint reaction force, so one is a tensile stress distribution, another is a compressive stress distribution. Now again, there was always this, we are critical, as I told you, about the results predicted by finite element models. After all, these are models, and you cannot believe results unless it is validated. So there was a new technique of digital image correlation, a non-invasive technique. So we had tested the pelvic bone specimen using this digital DIC technique. It is non-contact optimal metrology to measure full field stress distributions, surface deformations on practically any material subjected to a driving force. So the idea came from the aerospace industries. They have been trying to also measure stress and strain distribution in aerospace components. So we had actually adapted that method for testing bone samples as well. But remember, this is a full field. It gives you full field deformation patterns and stress strain distribution. So it's basically based on 2 cameras, and the specimen has a white paint, and you have to generate some black speckle patterns, basically randomized black speckle patterns, and through this camera we can track the deformation of the speckle patterns before and after loading. Okay, so there's a lot of mathematical transformations that is involved in getting out results based on this optical technique, sorry. Now, we had published this in American Society of Mechanical Engineering Journal of Biomechanical Engineering. So I'll just show you, just to give you what it gives and how we compare results. So on the left, you have the DIC results. Okay, so these are the 2 DIC results. So one is intact pelvis and comparing with the FE distribution on the right. So this is our FE distribution. And this is DIC results compared with the FE distribution for the strain distribution. We also compared the predictions with our age-old strain gauge technique. So the paint was removed from the surface of the analog bone, and then we had fixed these strain gauges and other strain rosettes, as well as some linear displacement sensors along 3 orthogonal direction, LDS 1, 2, and 3. And we modeled this whole thing. So this is the equivalent FE model that was generated, and we were in a position to compare the results. Now, here comes the results, even better than the femur. As you can see, R is equal to 9.956, standard error is about 70 microstrain, Here R is about 0.938 and standard error was about 75. So more or less, we can say that the FE models were valid predictor of the actually measured strains. If we compare the implant bone micromotions, implant bone relative displacement of micromotion, you can see how agreeable these results are along three directions. So we were in a position to investigate or further investigate what were the consequences of inclusion of a prosthesis. So we used another submodeling technique used in aerospace industry, basically to focus our attention on the acetabular, because this is our region of interest. So a pelvic bone is a large bone, but our main interest is towards this what happens in the domain of inclusion of this acetabular component. So we adopted this submodeling technique where we introduce cut boundaries and we transfer the displacements from the original mother model or the full model at the cut boundaries. So while incorporating this procedure, we are actually including the elastic properties of the remaining part of the pelvic bone, which we are actually not modeling. So it's a trick by which you can see here when we are comparing a full model with the submodel, we can see exactly similar stress distribution. However, if you look closely here and here, there is some deviation. This is because this model is made up of coarse size elements. Here the size of the element is smaller. Therefore, the description of the bone material properties is better, obtained in this case of the submodel as compared to the full model, which is rather coarse. So the finer the model, the better is your predictions. But overall, both the models gave consistent results, except few locations because we have a finer model in case of submodel. So the idea was transferring the nodal displacements at the cut boundaries from the full model to the submodel. So with that basic model at our disposal, we were in a position to assess all the failure mechanisms that came basically arise out of clinical feedbacks. Now this is on the left, you have the bone density. Just a moment. So this is basically the bone density for the intact bone. You can say immediate post-operative means intact because the bone density doesn't change immediately after surgery. After bone remodeling, this is the metallic prosthesis. You can see how bone density has reduced. So the blue means less. Just a moment. Why don't I see the... Oops. Yeah. The color blue is actually less bone density. When you move towards more red, it is more dense bone. So bone density is affected by the interface condition. So bone density is affected by the interface condition when we have a bonded interface condition as compared to debonded interface condition. Debonded means you are allowing some movement and you are applying contact elements to simulate friction between the implant and the bone. So interface condition affect bone density distribution after bone remodeling. But you can see that what can actually go wrong after implantation, how bone can remodel its structure after implantation. Now, we had taken up 3 processes designs. One was 3 mm ultra high molecular weight bearing surface, which was with this design with a horseshoe cutout, mimicking the structure of the acetabulum. So this was a CFR peak material, and peak is a material, CFR peak is a material that is evolving from the biomaterial side. And we had used a hemispherical peak cup as well, 3 materials. So here the total thickness of the prosthesis 1, which resembles a grain-rich cup, is 3 mm polyethylene plus 1.5 mm CFR PBT. So total thickness is 4.5. For the other two, both are 3 mm. Okay, but there is difference in the design. How does that affect bone density distribution after bone remodeling? So this is the immediate postoperative. You can see 4.5 mm thick. The thickness gives rise to more stiffer implant. Stiffer the implant, more are the adverse effects of bone remodeling. If the stiffness of the implant is less in 3 mm places, you can see less adverse effects. Prosthesis 2 and prosthesis 3. If you look at the sectional plots, you can easily see how bone density has reduced with bone remodeling for different thickness of the implant. So here, after bone remodeling with 3 mm thick implant, this is with 11 mm thick implant. So this is the trend, how the thickness of the design of the implant affects the bone remodeling after implantation. Now, we arrive at a point where we wanted to investigate or try to come up with optimized implant designs. And these optimum implant designs was sort of the objective was basically to reduce the failure mechanisms. Now, aseptic loosening of femoral stem is influenced by mechanical factors. As you can see, stem geometry, implant material, and length of porous coating. And we had undertaken this study to determine the optimal combination of these factors towards improved hip prosthesis. And this was the basic hypothesis and the objective. So it was necessary to investigate the optimal combination of these factors. Oops. It's a problem with the... Now, this is a highly mathematical intensive study where we have taken up the method of parameterization. As you can see here on the left, I try to explain it in a simple way that we have taken 4 key cross-section of the hip implant. So from the top 1, 2, 3, 4, and how the shape of the cross-section and the design of the implant together will affect the outcome. Now we started with standard tri-lock DPU hip stems, and you can see the 4 sections that I mentioned. And we wanted to parameterize these curves so that it evolves. There are about 2,500 shapes that evolved out of this parameterization. 18 design parameters were introduced, and the limits of this T, as you can see, were prescribed in the range of 0 to pi by 2. Now, what is this multi-objective shape optimization protocol? You start with a CT scan image, and then you generate a solid model, then do the virtual implantation, you do the automated volume meshing, do the finite element analysis using some ANSYS or finite element software or Abacus, anything, and then you introduce the non-dominated sorting genetic algorithm, okay, NSGA. So this basically is a optimization procedure, and the genetic algorithm scheme was found to be most suitable for this sort of contradictory design parameters, to analyze contradictory design parameters. And then basically you generate new shapes of the implant, and you keep on doing this unless you arrive at different results predicted by the different shapes of the implant. But before that, the fully automated shape optimization framework would like to discuss a little bit about the salient features of this fully automated shape optimization framework. The geometric parameters were introduced basically to characterize the tumoral stem shapes. Objective functions were formulated based on two common failure mechanisms of uncemented total hip replacements. And this optimization scheme comprises of parametric implant model generator, a script for virtual implantation, and an automated mesh generator and a finite element analysis kit. And finally, an optimization controller. So in order to integrate all these components, a master program was developed. A multi-objective genetic algorithm scheme is used to strategize design variables for a new implant model, and subsequently the master program was launched to evaluate the design. So what was the goal of the optimization? Was to minimize proximal bone resorption and implant bone interface stresses, which are common failure mechanisms. So again, just going through the generation of the finite element models in the details here, I think we need to go quickly through this slide because we have already discussed that. And then design variables, you can see the parameters A1 to A6, B1 to B4, and the degree of the curved segment, the values of P. So you have different on the medial side and the lateral side. So P1, P3, P4, P5, and there's P7, P6. On the lateral side is P2, P4, P6, and P8. So all these are shown here in the figure. So this is how you parameterize the design variables. A total number of 18 design parameters were introduced as design variables for the modeling purpose, and the design variables had lower and upper bounds and the functional constraints in order to achieve clinically admissible shapes. So there is also the recommendations of the surgeons that we cannot go below a certain dimension, we cannot go above a certain dimension. So the clinical feedbacks are considered as sort of constraints, functional constraints in the whole optimization procedure. The nature of the stem transverse sections varied from medial to lateral side by changing the degree of the cross-sectional parameters on both sides of the stem after maintaining continuity at the intersection of both segments. Furthermore, it was also required that the width and thickness of the cross-sections would decrease from proximal to distal end. Now, what is proximal? Proximal is on the top, distal is on below. Okay, these are clinical terms. Okay, so proximal means on the top, distal means below. So as we move from the top to the bottom, basically the width and thickness of cross-section should reduce. And this is required to facilitate ease of withdrawal of the implant in case of revision surgery. So all these recommendations has to be implemented in the whole procedure. considering all these cross-sectional features and important for the optimal designs, so we come up with the outcome. So if we see here that this is the optimization direction, we introduced a global interface failure function, and these are the two very objective functions we are trying to minimize, one on the x-axis, another on the y-axis, and this is the direction of the optimization results. So based on the multi-objective criteria and prescribed functional constraints and boundary conditions, a scatter plot of the feasible implant shapes have been obtained, wherein the direction of the optimization is indicated by the arrowheads. Now from that solution, we extract the Pareto optimal front. So Pareto optimal front was derived from the scatter plot, and we identify 3 optimally designed stem geometries, OSG 1, 2, 3. Okay, you can see in all these things, one thing is common: very narrow stem as we move from the proximal to the distal. Instead of single continuum solution, optimal solution, there is a set of trade-off solutions, which is generally known as the Pareto optimal solution. So Pareto optimal solution is a set which is derived out of the optimal solutions, a subset. The encircled markers indicate that dominant trade-off stem geometries, OSG 1, 2, 3, corresponds to stem profiles, different stem profiles. Now we come finally to compare that we have obtained this OSG 1, 2, 3, and how does it compare with the initial trilog stem from where we started. That is the standard shape of an implant, hip implant, used in the market. So you can see for a standard trilog stem, negative sign means reduction in bone density. So you have 55% bone density, minus 67% bone density. These are the proximal bone resorption evident in case of trilog hip stem. The moment you move to OSG optimal, it reduces to minus 18, minus 28, minus 4, minus 10. If I look at OSG 2, minus 22, minus 26, minus 6, minus 8, and here also a substantial reduction in the bone density. So we have come to a point to say that how mechanical factors actually govern the different clinical outcomes arising out of joint replacement. So there are many mechanical factors that influence. I think that message is clear to the audience. They may not be too much conversant with the criticalities of or the computer simulations of mechanical engineering, but I hope I could give you some sort of knowledge, transfer some knowledge that how the mechanical factors govern the design of the implants and how it affects finally the clinical outcome of a clinical surgery. Now, this was a new type of work that we had introduced. This is the last topic. I would like to cover it as soon as possible. Now, we have been trying to do some microscale simulation on bone ingrowth. And the background was just a moment, can I give a break? I need a little bit of water.
Yes, sir, of course.
Okay. Okay. So let us get back to the screen. So is it visible?
Yes, sir.
Just a moment. Is it? It's not moving. That's the problem. Can I I just want to stop presenting and then redo the whole thing. Is it? I don't think it is visible, right? Stop sharing. Hello?
No, sir, it is not visible. You have to
Just,
open your PPT.
yeah, I'm trying to do that. Is it visible now?
Yes, sir. Now it is visible.
Yeah. Okay, so welcome back. So this is a study which we have taken exclusively with the background that cementless implants rely on biological fixation. Okay. And bone ingrowth, which is necessary for fixation of the cementless implants, is known to follow the principle of bone fracture healing. So over the last 2 decades, we have observed that mechanoregulatory algorithms have been developed to quantitatively assess tissue differentiation. So this work is on predicting tissue differentiation. Okay? So how the design, particularly of the porous structure, to what extent bone will grow to facilitate osseointegration, that is bonding between the implant and the bone, that needs to be quantitatively assessed. And this study was an investigation that was necessary to gain an insight into the predictions of periprosthetic bone ingrowth means periphery of the prosthesis by two commonly used mechanoregulatory tissue differentiation algorithm. One was the phenomenological model, another was the cell phenotype specific model. So it consists of quite a lot of governing equations and simulations which are complex. So I'll try to present more in a more lucid terms so that it is understandable to the audience. Now, in this study, we have used a three-dimensional microscale FE model of implant bone interface. So we have taken up a Birmingham hip resurfacing implant as you can see, with a beaded structure of the implant. The objective was to quantitatively compare tissue differentiation predictions by cell phenotype specific and phenomenological algorithms. So study was focused on acetabular component, variation of regional bone material properties across the acetabulum, and variation in implant bone relative displacement across the acetabulum. Now, the mechanical factors that are known to govern periprosthetic bone ingrowth are presented here in this slide. So we are concerned about mechanical environment, which is affected by surface texture design, bone and implant material properties, both are important, and the boundary conditions. So all these three actually affect the mechanical environment, and this mechanical environment in turns affect the periprosthetic bone ingrowth. So we have used the simple diffusion-based phenomenological model. As you can see, this is the differential equation, and it includes cell proliferation and cell migration. A is the diffusion coefficient, and C is the concentration of the undifferentiated MSCs, that is the mesenchymal stem cells. Now, what are the differences between these two algorithms? Phenomenological algorithm is diffusion-based modeling. Cell differentiation is governed by mechanoregulatory principle, and explicit tissue formation is not modeled. However, in case of cell phenotype specific algorithm, cell migration, proliferation, differentiation, and cell apoptosis, that is cell death, are all modeled separately. More explicit modeling procedure. Extracellular matrix formation and tissue degradation are not considered in this model, and coefficients of all biological phenomena are governed by mechanoregulatory principle. Now, in order to account for the variation in bone material properties as well as implant bone relative displacement, the implanted acetabulum was divided into 13 regions. Okay, so as you can see, so this, for every region we have a separate microscale model, and corresponding to each 13 macroscale regions of the implanted acetabulum, the average regional elastic modulus is calculated and assigned to the respective microscale model. Now, as you can see here, we have few color codes. The red is 12 to 25% bone ingrowth, BI is bone ingrowth, black is 45 to 55% bone ingrowth, and purple is 60 to 70% bone ingrowth. Blue is 75 to 90% bone ingrowth. So we have color coded it so that it is easier for you to understand the range of bone ingrowths in different regions. And we are picking one of each color code for more detailed considerations. So this is basically the tissue differentiation predictions. You have red is immature bone, green is cartilage, and blue is fibrous tissue. Okay, in these representative regions 5, 7, 8, and 9, we are presenting the tissue differentiations after attainment of equilibrium. Okay. If we compare it with the earlier one was this was phenomenological based algorithm, that is diffusion based. The next one was more detailed cell phenotype specific algorithms. There are some differences, but overall it is not too different. If I try to compare these two simulations based on two different models, One is phenomenological results and other is self-phenotype specific results. We do see that they almost merge to the same solution, but there is a lateral shift in case of the self-phenotype specific modeling. Okay. This is a very important conclusion, that although there is not much deviations in the final outcome of the results, but there is actually a shift, a lag in case of when we are considering the more detailed self-phenotype specific modeling. Now, if we compare the evolution of the Young's modulus of the newly formed tissue layer, we can see there is a positive progression of increase in all the 13 regions. And the strains of this newly formed tissue layer for all these regions actually decrease with time. Now, we compared our predictions with different results that are available in the literatures, but there was no one-to-one comparison. So it was simply comparing some of the results that were available at our disposal. The average Young's modulus of the newly formed tissue was observed to increase with time in all 13 regions, and the strains were found to decrease, which is consistent with the basic theory of solid mechanics. The overall Fe predicted bone growth in our simulation was 45%, averaged over 13 regions, single acetabular component. If we compare it with clinical, histological, and radiographic studies, so this study from the year to 2013 gave about 46%, 76 different acetabular components, and from 1993, 33% from 9 different acetabular components. So if we compare very qualitatively, the results predicted by our model was not entirely incorrect. So I would like to acknowledge Indian Institute of Technology, Department of Biotechnology, New Delhi, University of Southampton, UKD, British Council, and NPTEL office for supporting the different studies and also the dissemination activities. And I thank you all for listening.
Thank you very much, Professor Gupta, for this insightful, comprehensive, and stimulating lecture.
Yeah.
And now we can move to the question answer session.
Yes.
So, dear participants, do you have any questions?
Yeah, I think there was some question posted already in the chat box, right?
But I don't find any question in the chat box.
Okay. Yeah, you're free to ask me any questions. Yeah. I thought I would actually physically visit Maulana College. I have some memories of that college. My uncle was Amitabh Gupta. He was in the English department, heading the English.
You are most welcome, sir. You are most welcome.
But after you invited me, I was I was given this sudden responsibility of leading the most sensitive center, that is the training and placement of biotechnology. And the last few months, it was horrendous experience of organizing things. And even if you have, there was a scope, I wouldn't have made it, because the whole phase 1 ends in 17th of December, day after tomorrow. So
Okay,
maybe,
sir.
yeah.
Yes, sir. Yes, sir.
Anything what you would like to ask, or anything? if you want anything more, you can write to me. I can send you publications if it is helpful for the students.
Thank you. Thank you, sir.
Anyway, thank you. I hope I hurriedly tried to write an abstract, and I hope it is useful.
Okay, so thank you once again,
Okay.
and thank you all the participants.
Good afternoon, Principal Sir.
Good afternoon. হ্যাঁ বলো।
Good afternoon, Principal Sir. Good.
A very good afternoon to everyone from the Teaching Learning Center, Maulana Azad College. And thank you to all the participants and all the dignitaries for joining with us in this valedictory session. Uh, First, we would like to request Dr. Krishnendu Dotto, Principal Maulana Azad College, to kindly present his address in the valedictory session.
Very good afternoon to all of you. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Distinguished representative of the UGC-MMTC University of Calcutta, respected resource persons, dear participants from across the nation, my colleagues and friends. As we assemble for the valedictory session of this online refresher course on Bioscience, Bioengineering Nanotechnology, we are not merely concluding an academic program that began on 2nd of December 2025. We are in fact standing at a reflective pause, one that allows us to look back at what we have gained, and more importantly, to look ahead of what lies before us. Over the past 2 weeks, from 2nd December 2025, this course has functioned as a vibrant intellectual commune, transcending geography, institutions, and disciplines. Screens may have separated us physically, but ideas, curiosity, and shared purpose have brought us remarkably close. This, perhaps, is one of the defining features of higher education in our times. That distance has diminished, but dialogue has deepened. We are, in essence, affirming a collective commitment to the future of higher education, one envisioned in the National Education Policy 2020 and shaped by the rapidly emerging landscape of digital university and technology-enabled learning. All of us are aware that the NEP 2020 urges us to reimagine the education as multidisciplinary, flexible, inclusive, and rooted in critical inquiry. So these refresher courses have been a living embodiment of that vision. By bringing together bioscience, engineering, and nanotechnology on a single academic platform, it has demonstrated how knowledge flourishes when disciplinary silos dissolve and conservations begin at the intersection. We must aware that in the framework of NEP 2020, faculty members are the central agents of transformation. Policy reforms, curriculum restructuring, digital infrastructure can only succeed when teachers are intellectually empowered, technologically confident, and pedagogically innovative. So refresher courses such as this serve precisely that purpose. They enable continuous professional development, promote inquiry-based teaching, and encourage alignment with outcome-oriented and learner-centric education. The online mode of this program is itself deeply significant. The future university will no longer be confined by physical walls or rigid schedules. Digital universities and blended learning ecosystem, as envisaged under NEP 2020, will democratize access, personalize learning pathways, and foster lifelong education. So this course has shown us how digital platform can become space of meaningful academic engagement, where ideas circulate freely, collaboration translates geography, and excellence is no longer limited by location. So for students of the coming decades, education will be modular, flexible, and skill integrated, allowing multiple entry-exit options, interdisciplinary choice, and seamless integration of research, innovation, and entrepreneurship. So as educators, this places a profound responsibility upon us. Our role is no longer confined in transmitting established knowledge. We are mentors of inquiry, facilitators of critical thinking, and architects of learning environments that prepare students for problems that do not yet have names. The classroom of the future will not merely ask, what do you know? But what you can imagine, integrate, and create. This is what the future of this education. So this refresher course has also reinforced a key message of NEP 2020, that research and teaching must be deeply interconnected. Exposure to contemporary research trends revitalizes classroom, inspire young minds, and nurture a culture of questioning. So when teacher becomes active learners, institutions evolve into dynamic knowledge hubs rather than a static degree awarding bodies. For Maulana College, hosting this program during our centenary year carries a special meaning. As an institution founded in 1924, we have journeyed through a century of educational transformation. Today, as we step into the second century, we reaffirm our commitment to the principle articulated in NEP 2020, that interdisciplinary, digital empowerment, academic excellence, inclusivity, and national integration. The true success of this refresher course will not be measured by its duration, but its long-term impact. New pedagogical practices, collaborative research initiative, digitally enriched classrooms, and students who are better prepared for a complex and interconnected world. As we conclude, let us remember that the university of the future is not merely digital, it is human-centric, value-driven, and innovation-oriented. Technology will be its tool, but wisdom will remain its goal. I extend my sincere gratitude to UGC-MMTC, University of Calcutta, our distinguished resource person, dedicated participants, and the entire team of Maulana College, whose efforts ensured the success of this program. With this thought, I wish each one of you continued growth, curiosity, and courage in your academic journey. Thank you. Jai Hind.
Thank you very much, sir, for your highly thought-provoking and insightful lecture. We would now like to invite Dr. Lakshmi Narayan Satpathy, the Director, UGC MMTTC, University of Calcutta, to present the valedictory address.
Before that, let us invite one or two participants to share their views regarding the how the program went through.
Sure,
One from
sir.
outside of the state and one
Sure,
from within our state.
Okay, so we definitely have a section for voices from the participants. So we are actually very eager to listen to the participants' insights and reflections about the full learning outcome, course experience, whether their aspirations were met, or whether they could learn anything new from this course, or anything which they will take back. The take-home message is the most important. So I would like to request the participants, if you would kindly share with us your valuable feedback.
From the lady participants from outside of the state.
Can I say something?
Yes.
Okay.
Please, yes.
So, good evening, everyone. I am Dr. Om Prakash Singh. I am currently working as assistant professor in the Department of Biochemistry, Banaras Hindu University. So, before attending this refresher course, which is particularly based on mostly on the nanotechnology, I can say, frankly, that I was not aware so much about the nanotechnology because I did my master's I did my PhD from the Department of Medicine in Institute of Medical Sciences, Banaras Hindu University. So my all research was totally on the clinical research based on the human. And the thing why I joined this course because since 2015 I have been hearing from my colleagues that there is a lot of advancement in the nanotechnology, and that has the clear potential of the diagnostic in use. So I was thinking that is it possible to make the very highly sensitive diagnostic tools based on, with by using the nanotechnology? So because I was unaware about the nanotechnology, how to use that technology in the clinical field, that was totally, not in my head. But by attending this course, I have learned, from the first day, I have learned the second lecture, which was based on the extracellular vesicles as a diagnostic tools. Then I realized that yes, within these extracellular vehicles, using with the help of the nanotechnology, we can enhance the sensitivity of our diagnostic tools. The thing is that whatever the clinician currently are actually facing the challenge, they are facing the challenge by the limitation of the rapid diagnostic test. Currently, very few RDT rapid diagnostic tests are available in the market, and whatever the available tests are in the market, based on that they have to treat the patient. And the currently available tests are mainly based on the serology test, and that has some limitations. So if we can develop some high sensitive rapid diagnostic test, that will add the decision making of the clinician. And I think I have learned a lot, and I have already, during this session I have already some concept in my mind after learning this refresher course. And definitely within a couple of years I will actually not I will start, after 1 or 2 months of this year, I will start some of the work on the nanotechnology. But whatever I have in my mind, that within couple of years I will have to have some nanotechnology based diagnostic tests, and this is the very important refresher course for me, I think. Thank you.
Thank you. So let us invite Dr. Arunima.
Yes, sir.
Yes.
Yes, sir. I would also like to share my experience. But first of all, thank you for providing me this platform to share my experiences. Sir, my name is Dr. Arunima Datta. I am from Chhattisgarh. I work in a government college, a government Vivekanand PG college, Manendragarh, that is in the newly formed district, MCB. And I'm an assistant professor in the Department of Zoology and the departmental head. And first and foremost, I would like to offer my earnest gratitude to the UGC MMTTC of Calcutta University and the Teaching Learning Center at Maulana Azad College, Kolkata, for organizing such a wonderful refresher course on biosciences, bioengineering, and nanotechnology. On my behalf and as well as on behalf of all the participants, my fellow colleagues, I extend my heartfelt gratitude to the chief patron, Professor Ashutosh Ghosh, the VC of University of Calcutta, patron Dr. Krishnendu Dotto, Principal Maulana Azad College, Kolkata, the advisory committee members, Sir, specifically Professor Satpathy, Director of UGC MMTTC of University of Calcutta, The coordinator of the program, Dr. Shom, and the assistant coordinators, Dr. Ajanta Mukherjee and Dr. Shubhadeep Shamanto, along with all the esteemed members and supporting staff. The skillful management and scheduling of this entire curriculum, of this, what I say, fortnightly odyssey of interdisciplinary studies, where bioscience, engineering have been enriched and advanced in connection with nanotechnology, were truly commendable. On behalf of my colleagues who are from various states of India, I can confidently state that the knowledge we have gained and the discussions that we have shared will probably impact our future academics and research endeavors. Sir, I have attempted to summarize this experience in my own way, and I have named it as the Nano-Cloning Quantum Symphony. If you give me permission, I would like to read it out. So do I have your permission?
Yes, please.
Thank you, sir. The Nano-Cloning Quantum Symphony. The robotic arm begins to twitch, a BME vision, but not a technical glitch. Extracellular vesicles finely sprayed, serve diagnostics, come what may. The NPs are state-first allies, heals cancer, kidneys, countless vials. Green, silver, and nano fertilizers rise, nourishing crops with eco-wise guise. When venom strikes with lethal art, nano antivenoms play their part. We ventured deep where proteins bend, on polymer surfaces, firm yet friend. Organic reactions pulsed within where medicinal chemists start to win. Yet, stand alert, the entamoeba cyst, a fortified wall, few can resist. Quantum computing then came to light, rewriting genomes, sharpening sight. In plants, we learned nano-elicitation's role, which boosted metabolites and enriched as a whole. We probed antibiotic-laden streams, battling AMR in unseen schemes. Soft ion mass spectrometry revealed anew molecular medicine in clearer view. RSM refined the data flow, optimizing paths we seek to know. With bioprocesses steady, controlled, as well as clear, this RC-BBN stands resilient, refined, and premier. Thank you, sir. Thank you, everyone.
Arunima. So beautifully summarizing the entire program.
Excellent,
We have
excellent.
wonderful,
Thank you.
big applause to her. And
Wonderful approach.
yeah,
Thank you, sir.
so I am really thankful to the wonderful leadership from Professor Dr. Krishnendu Dattu, Honorable Principal of Maulana Azad College. So he has shown the way that how a college can not only manage but also how wonderfully organize a relatively difficult area, because the divergence of this program from the bioscience to bioengineering to nanotechnology, it's a wonderful, divergent, but most cutting edge discussions took place in this platform. And definitely credit goes to, again, the wonderful leadership from Professor Dr. Shom, and also the coordinated by Dr. Ajanta Mukherjee and Professor Samanto and the entire team behind. So I'm really grateful and thankful to you, all of you, sir, particularly Principal, sir. So what we have come to know that you have not only this entire program led to its final completion. So I'm going to report to our Vice Chancellor also that it is possible to organize such programs in future in some of our best colleges affiliated to the university. So these may not be restricted to our university departments alone.
Correct.
Now, The entire exercise of the refresher courses is to make a synergy among the various faculty members and also the senior faculty experts coming from different institutes to have a collaboration in future so that our entire society can live in a better way. Our descendants, the coming generations, they can be the better successors using the technologies, and also our forefathers, our parents, grandparents, they are also feel comfortable with the new changes and challenges. So it is the entire society can live in a better way with some welfare. Technologies are not for the means of technologies, also for change also only, but to live in a better way, how to intervene for our human welfare, taking into consideration the entire environment of the sentients and also others, living creatures. So in that way, the bioscience has a greater role to play, and engineering and nanotechnology, we cannot deny their roles in this drastically changing world where technology is having a greater role to play. Regarding some of the administrative issues, again, I would like to say that some of you might have, and while enrolling in the UGC MMTTC site, that you have given the district or the place of your residence, but that should not be. You please recheck it. It should be your institution's place or district or the prominent location. So otherwise in the certificate the same mistake will be there. So you just correct it in the UGC site, and we are going to prepare the final certificates accordingly. And today by midnight you are going to get the provisional certificate come release order by our honorable coordinators. And in future, definitely we are planning to organize such programs on site mode so that you can visit some of our labs also, because we have a very good nanotechnology lab in our university. So you have missed this time, but you are invited to take part some of the programs. You can also collaborate, do some research with our learned members of the faculties from physiology, zoology, botany, biochemistry, many other streams are there. Senior faculty members, they will extend their hands. And also keep in touch with our the college faculty members, the host organization of this program. They are also wonderful people. So far you know that, and some collaborations definitely you can have in future. So thank you very much for choosing our MMTTC. You are also going to choose some of our programs. We are going to offer one program on NEP sensitization and orientation in January. So please inspire your colleagues and research scholars also. They can join in this sensitization program, which is free, and only 3 hours lecture they have to attend in the afternoon. So I have a program for a PhD Viva. I have to leave, but you can continue. Sir, thank you very much for shouldering the responsibility.
Professor
Okay.
Satpathy from the
Yes,
platform.
sir.
Thank you.
Professor Satpathy.
Yes, sir.
Thank you. From this platform, I would like to request you that we want to hold another refresher course from your organization, from your UGC-MMTC on the physical sciences. So this particularly on the bioscience. So from this platform, I request you, if you allow us to conduct a refresher course on artificial intelligence, machine learning, along
Yes,
with
sir. I'm going to discuss.
other
I'm
part
going
of
to discuss.
physical
Yes,
sciences
I'm going to discuss
in the
with you.
coming session.
Sure, sure. I'm going to discuss with you in detail. Okay. So first of all, I have to report to our Vice Chancellor that this program was wonderfully conducted, and Professor Datto has done it very well.
Okay, thank you. Thank you.
Okay. So please continue. I am leaving with your kind permission. Okay. Okay.
Thank you, sir, for your encouraging words, and thank you very much. Continuing.
Dear participants and coordinator, I am also leaving. I have another meeting. So you continue the program.
Okay, sir.
Thank you all. Thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.
So, continuing the valedictory session, Now I would like to request Dr. Deepak Kumar Shom, the coordinator of this program, actually the backbone of this program, to please give his report.
Thank you, Dr. Ajunta. Respected principal, MMTTC, Calcutta University, my dear participants, and esteemed colleagues, it gives me immense pleasure and a deep sense of responsibility to present the report of the MMTTC UGC refresher course entitled Biosciences, Bioengineering and Nanotechnology 2025, organized by the Teaching Learning Center of Maulana Azad College, Kolkata, under the aegis of MMTTC University of Calcutta. Organizing a national level refresher course of such magnitude has been a new and significant challenge for the organizing faculty members of our college. The successful implementation of this program demanded careful planning, academic commitment, and time management, especially while balancing a huge teaching load at both undergraduate and postgraduate levels. I am proud to state that despite these constraints, the organizing team ensured smooth execution of all academic sessions without compromising regular teaching responsibilities. This reflects the dedication and professionalism of our faculty members. One of the most notable strengths of this refresher course has been the excellent selection of resource persons. Experts were drawn from diverse disciplines and premier institutions across the country, ensuring a truly interdisciplinary approach. Their deliberation provided the participants with the right academic flavor of the course title, seamlessly integrating concepts from biosciences, bioengineering, and nanotechnology, and highlighting their contemporary relevance in research, teaching, and innovation. On behalf of the organizing committee and the Teaching Learning Center of Maulana Azad College, I express our sincere gratitude to MMTTC University of Calcutta for entrusting us with the responsibility of organizing such a prestigious national level refresher course. This confidence reposed in our institution has been both an honor and a motivating force, encouraging us to uphold the highest academic standards. I would also like to place on record my heartfelt thanks to all faculty members and staff of Maulana Azad College who extended their tireless and wholehearted support at every stage of the program. Their cooperation, academic, administrative, and logistical, has been instrumental in the successful execution of the course. Finally, I must emphasize that the most valuable and enriching component of this program has been our fellow participants. Their enthusiastic participation and insightful interactions have added immense value to the course. Their constructive feedback will undoubtedly shape the future direction of our academic endeavor and will help us designing more impactful and relevant faculty development programs in the years to come. With these words, I once again thank all stakeholders, MMTTC UGC, MMTTC University of Calcutta, resource persons, faculty members, staff, and fellow participants for making this refresher course a meaningful academic experience. In advance, Happy Christmas and Happy New Year 2026. Thank you all.
Thank you so much, sir, for beautifully wrapping up And it was very aptly said, everything. Thank you, sir, once again for being the continuous inspiration behind the scene and encouraging us, for giving our best always, even when we were sometimes maybe not very feeling down, but you cheered us up. Thank you, sir, once again. And
Thank you. Thank you.
yes, we would. I would actually again like to request if there is any participant who would like to share their anything with us, anything maybe they had thought, or maybe they got to hear, or maybe didn't hear. Would like any suggestion, anything, maybe anything negative also, which they found during the program, that also we would like to hear, apart from the internet issues. Because to be very frank, from the morning today, TLC has been experiencing lots of internet issues. And so behind the scene we were discussing that in the very last day it is us who are experiencing a lot of internet issues. And so when we are seeing the messages of the participants that they are having network issues, so we didn't know what to say, because it was a mutual problem, it seems.
Hello,
But
am I visible?
yes, you are visible
Yes,
and
yes.
audible. Please
So
share with us.
I have already shared my comment in comment section.
Okay.
I will like to add one more point. So with this good line of speakers, the only improvement which can be done is offline experience. Other than that, everything was fine. So if this list of speaker is there in offline classes, that would be something really great. But there are limitations of the program. So otherwise, it was well organized, and I was really impressed with the quality of speakers and the way the program was conducted. Thank you very much.
Thank you so much uh, for the positive words. We This was a very first experience, as said by sir. We did not have any experience in conducting any this a course of this stature in the national level. So it was very challenging for us, but it was a learning experience. We took it as a challenge on our end, and along with continuing with our classes, we tried to take as many classes as was possible in our daily routine. We also looked
Dr. Prajit, Dr.
yes,
Prajit,
Prajit
uh,
Nambiar, yes.
you can share your experience. Dr. Prajit. You are not audible. You are not audible.
Unmute, unmute, ask him to unmute.
Yes, sir.
One question again, half an hour. Hi.
Sir, the mic is showing mute.
Yeah, is it better now? Like, I'm
Yes,
audible?
now it's unmuted. Yes.
Yeah, actually, what I wanted to say was basically second what Dr. Chandan said, that it would have been great if it was an offline course. But I know the limitations are there, and all the lectures were truly amazing. The speakers as well as the topic of the lectures, and most of all, I would like to thank the coordinators of Maulana Azad College and whoever was behind this whole organizations, because it has been so perfect in the organization execution and the punctuality of the whole course. And I would greatly appreciate you all for this, and I would recommend all my colleagues to consider Maulana Azad College for refresher course.
Thank you.
Thank you, sir. So,
Thank you.
Okay. Now I request Dr. Ajanta Mukherjee, Associate Professor, Department of Chemistry, Maulana Azad College, to brief online feedback and certification of this course. Ajanta.
Yes, so we have almost reached the very end, and the end goal is to get the certificate from MMTTC CU. So before that, today, after just as soon as we end the program in the evening, first we will send the provisional certificate come release order. That will be sent first to you. Then after that, we will send a feedback form. It will be a detailed feedback form which will be divided into sections. The first section is perhaps the most important one, where we will again take the details, name, affiliation, then department, designation, district, state, and as was pointed out by Professor Shatpati, you must write the name of the college to which you are affiliated and the district where the college is situated, and not the home district of the home address. So everything is with the affiliation, and this you must fill up very carefully, because this will be sent by us directly for the certificates. That means if there is any correction in any spelling or anything, we will send the data which we get from the feedback form to the MMTTCU, and they will directly incorporate that data in the certificate. So the first section is very important, and after that there is detailed feedback about the resource person and other about the full course organization, etc. So that part you must fill up and submit the feedback form. After we receive the feedback form, please try to submit it by within say 1 or 2 days, because as I said, we require the final data which you will send us regarding your name, affiliation, etc. So we will send it along with the grades, and then you can, after we receive there are 40 participants, so after we receive the full data for the 40 participants, we can send it to the MMTTC CU, and then as soon as we send it, then you will, after that MMTTC will send you the final certificate. So this is the whole process for the certification. Okay, and so now I would like to request Dr. Shormishtha Bonik, Associate Professor, Department of Zoology, to please present the vote of thanks.
Raja, Madam.
So, good afternoon, everyone. It is both an honor and a privilege to appear before you today as we bring this enlightening online refresher course to a close. As we approach the end of this course organized by Maulana Azad College, Kolkata, under the aegis of UGC-Malaviya Mission Teachers Training Center, MMTTC, University of Calcutta, I, Dr. Shormishtha Bonik, Associate Professor of PG Department of Zoology, Maulana Azad College, Kolkata, would would like to deliver the vote of thanks on behalf of the organizing committee of this course on Bioscience, Bioengineering and Nanotechnology. Today marks the culmination of a remarkable journey. As we gather for this valedictory occasion, we pause to reflect not only on the achievements that brought us here, but also on the collective spirit of all the members of the organizing committee who made this endeavor possible. A special note of thanks must be conveyed to Professor Ashutosh Ghosh, Honorable Vice Chancellor, University of Calcutta, for selecting this college as a venue and center for organizing such an online refresher course. This initiative is historic as Maulana Azad College becomes the first government college in West Bengal to have the opportunity to conduct such an online refresher course under the UGC MMTTC framework. What makes this achievement even more momentous is that it comes during the centenary year of our college, adding a defining academic milestones to the landmark year in our institutional history. Thanks also to our principal sir and the patron of this organizing committee, Dr. Krishnendu Datta, for his vision, leadership, and unwavering guidance that have been the cornerstone of this endeavor. He reminded us that excellence is not a singular act but a sustained habit, and your encouragement has inspired us to aim higher. Thank you, sir. A special note of thanks is due to Professor Lakshminarayan Shatpathy, Director UGC MMTTC, University of Calcutta, Dr. Shampa Datta Gupta, Coordinator IQAC Maulana Azad College, Kolkata, and Dr. Dabir Ahmed, Secretary Teachers Council, Maulana Azad Kolkata, for their constant guidance and encouragement and invaluable support throughout the course. We also extend our heartfelt thanks to Dr. Deepak Kumar Shom, Program Coordinator and HOD, Department of Zoology, Maulana Azad College, and to the Assistant Coordinators, Dr. Ajanta Mukherjee, Associate Professor, Department of Chemistry, and Dr. Shubhadeep Shamanto, Assistant Professor, Department of Chemistry, without whose tireless efforts this workshop would not have been a success. From meticulous planning to flawless execution, their leadership was instrumental to the successful conduct of this workshop as they consistently transformed challenges into opportunities. I would also like to take this opportunity to gratefully acknowledge. Excuse me, Raju. Excuse me, Rajoshi.
Rajoshi,
Put off your mic.
Rajoshi, please mute.
I would also like to take this opportunity to gratefully acknowledge each member of the organizing committee by name. Myself, Dr. Shomishta Bonik, Dr. Sudipto Chakraborty, Postgraduate, Department of Zoology, Dr. Devjani Sarkar, Postgraduate, Department of Zoology, Dr. Debraj Biswal, Postgraduate, Department of Zoology, Srimati Bipasha Roy, Department of Microbiology, Dr. Debolina Bhattacharya,
Dr. Bonik, একটু আস্তে আস্তে প্লিজ
Okay. Dr. Debolina Bhattacharya, Department of Microbiology, Dr. Aftab Hossain Mondol, Department of Microbiology, Dr. Mazharul Abbasi, Department of Microbiology, Dr. Dipan Odhikari, Department of Botany, Dr. Selima Khatun, Department of Botany, Sri Shaumo Mukherjee, Department of Physics, Dr. Mahfuzur Rahman, Department of Physics, Dr. Rajendra Shaha, Department of Chemistry, Dr. Orijit Kundu, Department of Chemistry, Dr. Shubroto Rana, Department of Statistics, Dr. Gopal Dash, Department of Mathematics, Dr. Nilanjana Chatterjee, Postgraduate Department of English, Dr. Nivedita Bain, Department of Sociology, Dr. Titasha Sinha, Department of Sociology, and Sri Uchchal Shanyal, Department of Commerce, whose dedicated efforts behind the scenes ensured that every detail was meticulously attended to. The collective dedication, cooperation, and teamwork of every member of organizing committee are truly commendable and deserve our sincere appreciation. We extend our gratitude to the keynote speaker, Padmasri Ajay Kumar Rai, former director, IIEST Shivpur, for sharing his insights on integrating nanotechnology and biosciences. We must also thank our 33 number of esteemed speakers of premier national institutes and universities who deliver thoughtful lectures on innovative research across the interdisciplinary fields of bioscience, bioengineering, and nanotechnology. They enlightened us on the cutting edge research being carried out in different leading and reputed universities and institutes all over India. We are extremely grateful to Dr. Madhumita Manna, Honorable DPI Madam, for delivering a lecture in this course despite her busy schedule. We must thank our 5 esteemed adjudicators for taking their time to evaluate the participants' presentations and write-up, namely Professor Prabir Kumar Das, Professor Subhash Bhattacharya, Professor Timir Baron Jha, Dr. Partho Roy, and Dr. Shubhadeep Samanto. We also take this opportunity to express our gratitude to all faculty members, non-teaching staff, administrative personnel, and stakeholders of Maulana Azad College who were associated with this program, both directly and indirectly. Their cooperation and support were invaluable to the successful conduct of this refresher course. We'd like to place on record our special thanks to Mr. Supriyo Das of Skyline Web Apps for his continuous, efficient, and dependable technical support, which played a crucial role in ensuring the seamless conduct of this online program. As we close this chapter, let us carry forward the lessons of collaboration, resilience, and shared purpose. This valedictory moment is not an end, but a bridge to new beginning. May the spirit of unity we have built continue to guide us in all our future endeavors. Thank you, and may success follow each of you in your academic journeys ahead. Finally, before we end, we'd like to introduce you to the full backstage team of our moderators. Moderators, in order of appearance, Dr. Ajanta Mukherjee, Department of Chemistry, Dr. Aftab Hossain Mondal, Department of Microbiology, Dr. Nivedita Bain, Department of Sociology, Dr. Debjani Sarkar, Department of Zoology, Dr. Shubroto Rana, Department of Statistics, myself, Dr. Shormishta Bonik, Mrs. Bipasha Roy, Department of Microbiology, Mr. Shoma Mukherjee, Department of Physics, Dr. Rajendra Shaha, Department of Chemistry. Rajendra is there. Dr. Shubhadeep Samanto, Department of Chemistry. Dr. Nilanjana Chatterjee, Department of English. Dr. Orijit Kundu, Department of English. Dr. Orijit Kundu, Department of Chemistry. Dr. Selima Khatun, Department of Botany. Dr. Debraj Biswal, Department of Zoology. Dr. Deepan Odhikari, Department of Botany. Thank you. Dr. Debolina Bhattacharya, Department of Microbiology. Dr. Titasha Sinha, Department of Sociology. Dr. Mazharul Abbasi, Department of Microbiology. Dr. Abhishek Ghosh, Department of Microbiology. Dr. Ujjwal Sanyal, Department of Commerce. And finally, Dr. Mafazur Rahman, Department of Physics. So now we would end by a virtual group photograph. Participant, please keep your camera on. We will take the photograph in 2 sections. I am handing over the mic to Ajanta.
Okay, participants. One thing is that in the screen, maximum 49 is being allowed. So, what we will do is that we are ready with the screenshot app and everything. So, in front of me, those of whose photographs are coming, I will read out their names after I take the screenshot. So then you can leave then the program and allow the other group of participants to come in front, because they are not allowing more than 49 in one shot. So that is one restriction. So okay, now let me just read out the names whose faces are appearing. Okay, I'll just call out the names whose faces I can see. সুজাতা ধার দত্ত, নবনীতা ঘোষ, মানসী মণ্ডল, রাজর্ষি ঘোষ, অরুণব মুখার্জি, অর্পণ দাস, অরুণিমা দত্ত, পরমা রাহা, অন্বেষা চৌধুরী, ওপি সিং, চন্দন সিং, অজয় কুমার দাস, নিবেদিতা নাগ, অভিজিৎ বিশ্বাস, সৌমভ চ্যাটার্জি, অভিক চৌধুরী, সৌভিক মিত্র, ভাস্কর দাস, অরিজিৎ দাস, অয়ন দাস, মিতালি হালানকার, Dr. Kuntal Kanti Goswami. So we will first take the screenshot with all of you. Okay, and then we will go for the next set of participants. Okay, right. So all of us, let us be ready in 1, 2, 3. 1 second. So ready. Okay, I will again take one more shot. I will take one more shot. So please be ready in 1, 2, 3. Okay, so we have taken the photographs still Dr. Kuntal Kanti Goswami.
This person may
Thank you. Leaving now.
So, yeah, or you can just switch off the videos, then the other group will be visible. Those who are switching on their videos, they will be visible in the tile. Hide tiles without videos. So we are hiding the tiles without video. So those of whose photographs have been taken, if you switch off the videos, then you will not be visible. The other group will be visible.
Yes, other group.
Okay, so now we have Dr. Rakhi Chakraborty, Dr. Kaji Manjur Ali, Dr. Kaushik Sarkar, Dr. Deepan Adhikari, Dr. Namrata Rai, Dr. Charuchand Hajda, Selima Khatun, Abhishek Mukherjee, Abhishek Ghosh, Aftab Hussain Mondol, Bipasha Rai, Anita Gandhe, Sumanto Baski, Prajit Nambiar, Abhishek Basu, Shyam Sarkar, Durga Bhattacharya, S.K. Basiruddin, Tondrima Shil, Sonali Rai, Devlina Bhattacharya, okay, Devraj Biswal, Durga Bhattacharya.
But Devraj is my participant.
Okay. Okay, please don't fluctuate. I need, okay, be steady all. Dr. Devlina is not here, but we will again take another, by rotation we will take group photo. Okay, so we have taken, okay, let me take just one more shot. Okay, done. So next group, please come forward. Dr. Devlina Sarkar. Yes. Have I called out all the names? I don't think so. What about Annesha Chaudhary?
Yes, madam, you have called my name.
Okay. Then it's fine. I don't want to miss anyone. Okay, let me take the screenshot. Right. Come. Okay, we are joined by one more moderator. Okay, Dr. Devjani Sarkar, please stay for a photograph. Right. So, hopefully everyone's name has been called out.
Okay, thank you, ma'am.
Okay, we will make a collage of the photos and we will send it by email. We will make a photo collage. Hopefully everyone's photo has been taken. Fingers crossed. Okay, so Dr. Namrata Rai, we would love to hear from you at the end. Please, it's a request from the team. Thank you for so actively participating in every session.
Madam, my internet is causing some problems, so I'm not switching on my video.
No problem.
I hope you can listen to me. I don't know because I can't listen to you all the time.
বাংলাতেই
Sometimes
বলুন
it is dropping.
বাংলাতে বলুন আরো ভালো লাগবে আমরা বাংলা দিয়ে শেষ করি সরি we will
এতবার না এতবার মানে ইন্টারাপ্ট হয়ে যাচ্ছে আমি বুঝতে পারছি না যে আমার অসুবিধা নাকি ওই দিক থেকে অসুবিধে কে কাকে শুনতে পাচ্ছে না আমি বুঝতে পারছি না যাই হোক আমি অলরেডি লিখেই দিয়েছি যেটা বলতে চাইছিলাম যে but there are also participants from outside of the state who won't understand
please
Bangla.
go ahead. Yes, go ahead. No problem.
First of all, thank you to the entire organizing committee and to the team of coordinators who have made it such an enriching experience. From my point of view, I can tell you that the prime reason I wanted to do a refresher course in an interdisciplinary area and not from my subject, not in chemistry, because just to move out of my comfort zone and challenge myself to learn about new innovations and advances at the interface of pure and life science, of medicine and engineering, of academia and industry. And at the end of this 12-day refresher course, I am very elated to say that I think I have met that goal. So that is all credit to you, because you have arranged talks and lectures from all multidisciplinary domains. All the resource persons were extremely kind and nice to very interact with us very freely, and they have indeed expanded our horizons of knowledge and also rekindled our curious minds, which sort of in our daily monotonous year of teaching, sometimes we tend to forget the students which are still quite alive within us. So that was a very nice experience altogether. All the lectures were versatile from various domains, and a few of them were known to us, so we had the opportunity to go into further depth, and some few things were absolutely new, so we learned a lot from that. The only thing I know, it was a very tight schedule and it was also a lot of time constraint, but if there was a little bit more time in our own presentations and if we got to interact a bit more, that would probably have been the icing on the cake. That's it. There's no negative comment or anything I don't have. All I have, I'm leaving this course is with a lot of positivity and a lot of knowledge and inspiration. Thank you very much.
Thank you.
Okay, thank you so much. Uh, it was really a very mutually
Exactly.
benefiting course, I
Exactly,
think.
exactly. We also started a new venture and faced lot of problem, and day to day we solve also that. So,
Yes, it was a really a problem solving skill thing for us also. Every day we would have some thing to overcome, new thing. So okay, so let us do it this way, or what will be because to be very frank, where I always thought in terms of the participants only, because once upon a time
exactly.
we also
have to go through this.
we went through the refresher course, so I was always thinking that what would be convenient for the participants. So we always thought in terms of the participants that yes, they should get the schedule early on, they should get the abstracts, they should get the PowerPoint and the link, video link, because the schedule is very tight and there is no extra time. That's the thing.
So, all well, that ends well.
Yes, very aptly said.
Very happily we will conclude this session.
Yes, we would like to wish everyone advance Merry
Exactly.
Christmas,
Merry
advance
Christmas.
Happy New Year, as the year is
And
also
also-
ending.
Exactly. Also a
Thank
very
you, madam.
long and long successful academic journey to
Thank
all.
you, madam.
Okay, thank you.
Thank you. Thank you all.
Thank you.
Thank you, everyone.
Thank you, everyone.
Thank you. Thank you.
Thank you, everyone.
Thank you, madam.
Thank you.
Thank you, everyone.
Thank you, everyone.
Thank
So
you,
today,
madam.
after you leave, then we will end the session.
Okay.
Camera to turn off.